Hello guys, I am Praj Naiman and I will be your instructor throughout this journey into the fascinating world of networking. So let's go. Sorry. So about before starting it, let's get to know about what is the real meaning of computer networks. So it defines as a set of nodes, a set of nodes, wait a minute, a set of nodes connected by communication links. These two terms, nodes and links, are the key words for this networking. Everything in networking comes down to these two concepts. Think of it like a road system. In a city, you have buildings and you have roads. Without buildings, roads are useless, and without roads, buildings are isolated. Similarly, in networks, you need both nodes and links. Nodes. Uh, so let's go deeper into nodes. A device capable of sending or receiving data. See, sending or receiving data, both beliefs. Okay, together they form a network. It's a node or a device capable of sending or receiving the data. So examples of nodes are computers, servers, printers, smartphones, bridges, routers. It goes on. Everything we use is mainly use of nodes. So next thing is communication links. So links forms gives a medium that carries the data between nodes. So remember, nodes plus links is equals network. Okay. So next thing, the next important thing is communication links. Communication links can be of two types: wired links and wireless links. Wired links, it mainly uses physical medium like cables to carry data, and wireless links mainly uses air, which carries data through radio waves. So if it's wired links example is Ethernet cables and fiber optic cables. Next is examples for wireless links is Wi-Fi and Bluetooth. So let's go to the next one. So end devices and intermediary devices. What are end devices? End devices. These are the source or destination of communication. Think about sending an email. Your computer is the source. Your friend's computer is the destination. Phones, printers, servers. If data starts or stops there, it's an end device. End devices are what we humans directly interact with. Intermediary devices are shown here. Like these forward data from one point to another. They are like traffic cops or postal workers. They don't create data. They don't create data. They will just and they don't create data and they don't consume data. They are just they just help it reach its destination. For example, we have routers, switches, hubs, bridges. These are all intermediary devices. You don't directly use them, but without them, your data couldn't travel across networks. Okay. So the next thing is network terminology. So as a computer network student, as I started learning computer networks, I came across some difficulties. Like there is a different way of vocabulary. Like network has its own language, its own jargon. You will hear terms like IP address, MAC address, protocol, package, and if you don't know what these mean, you will feel lost. Right. Before diving into the core concepts of networking, let us see some uh, the network term, fundamental networking terms, which helps us to understand, which helps us to make learning much easier. So let's dive into this. So first of all, link. We actually discussed this earlier. the physical or wireless medium that connects nodes, that is link. Then protocol. This is a very crucial thing. A set of rules that governs how data is transferred, transmitted and received. First of all, why do we need rules? Imagine if everyone on the road drove however they want. Chaos. Similarly, for computers to communicate, they need agreed upon rules. Examples include HTTP for web browsing and FTP for file transfer and examples and etc. Don't worry. Next thing is third, packets. A unit of data transmitted over a network containing both actual data and routing information. When you send data over a network, it doesn't travel as one big chunk. It's broken into smaller units called packets. Each packet contains two things: the actual data you are sending and the routing information. Like routing information is like the address, the destination address or the source address. It differs. Okay. Next IP address. So as you can see, IP address is numerical address for your computer on a network used when devices want to connect. It's like every computer has its own address. So through that only a group of computers will communicate. Okay. Next is MAC address. Physical hardware address permanently assigned to network device at data link layer. So what is MAC address? This is a physical hardware address. Before we seen is a software based address. Here it is a physical hardware address. It's permanently burned into your network card when it's manufactured. So it's like it was given by birth. That's it. Think of it like your device's fingerprint, unique and unchangeable. Isn't it right? Next thing is IPv4 and IPv6. Two types of IP address. IPv4 is older, IPv6 is created to address shortage of IPv4 addresses. Self-explanatory. Yeah, let's go. Host name. Human readable label for a network device. Human readable label for a network device, easier than remembering IP addresses. And this is the human readable name. Instead of remembering some 172.217.164 blah blah blah, you just remember google.com. Much easier, right? Your computer translates host names to IP addresses behind the scenes. Okay. Next thing is, let's go, frames. So what is frame? Combination of layer 2 frames. It's similar to a packet, but it's a different layer. A frame is the combination of layer 2 headers used to carry packets from source to destination using physical addresses. Think of a frame as the envelope that holds the packet. Don't worry too much about layers yet. We'll cover them in advanced courses. Second, NAT, Network Address Translation, used by routers to share a single public IP address among many devices on a local network. You have one public IP address from your internet service provider, but you have multiple devices at home: laptop, phone, tablet, TV. How do they all use the internet with just one IP address? That's what NAT does. Your router uses NAT to share a single public IP among all your devices. It's like a mail room. It's like a mail room in an apartment building. One building addresses, but the mail room sorts letters to different apartments. Okay. Then finally, crosstalk, undesired effect where one circuit interferes with another. eliminated by proper cable shielding. So, understanding these terms will help you grasp networking concepts more effectively. So guys, let's enter into the types of computer networks. Understanding LAN, MAN and WAN. So computer networks are classified based on geographical coverage. Geographical coverage. So it can be divided into three: LAN, local area network; MAN, metropolitan area network; WAN, wide area network. So LAN as the local area network. It's self-explanatory, right? It's in a small geographical area. Metropolitan area network, it's a city-wide coverage area. Okay. Next, WAN, wide area network, large geographical area. Yeah, large geographical area. Let's go to the next thing. Coverage. This is the type of network you interact with most day in daily life. Your home network, that's a LAN. Your office network, LAN. School computer lab, LAN. Coverage, limited area. Could be your residence, school, office building or university campus. The maximum range it could proceed with this 1 to 2 kilometers. Why this limit? Because the physical cables and wireless signals work better over shorter distances. Use cases. What are the use cases? What are the use cases? Look at those badges. Home networks where all your devices connect to your Wi-Fi router. Yes. See, next thing is metropolitan area network. Its coverage is larger than the LAN, which has a maximum of, it could cover like a city, two cities, like that, could connect many things. So this connects multiple LANs within a city or metropolitan area. So instead of just one building, we are talking about connecting different locations across the city. Example, a supermarket chain with 4 branches across the city connecting their networks for inventory sharing. Yeah, it's analogy, right? It's analogy. So a router connecting branch 1, branch 2, branch 3 and branch 4. So each branch is like a LAN. Okay. So this router controls everything. So next is, wait. Now let's move to the biggest category, WAN. It spans large geographical areas, countries, continents, or worldwide. Okay, large geographical areas. We are talking about countries, continents, or even worldwide. When you access a website hosted in another country, you are using a WAN, right? Key characteristics. It's telecommunications network. Communication at large distances connects LANs and MANs across regions. Example, office in New Delhi communicating with office in Chennai. Look at the diagram. We have two LANs, one in New Delhi and one in Chennai. These cities are over 2000 kilometers apart. Between them is a blue complex infrastructure making this connection possible. Let's go to the next one. Benefits of networking. Benefits of networking is resource sharing, uh, fast data transmission, reduce infrastructure costs by sharing resources across the network, seamless data transfer and communication between the devices. So let's move. So in the next slide, we can see a a brief comparison on LAN, WAN and MAN. So the pattern is so clear, that is, as we increase geographical coverage, speed decreases but cost increases. LANs are perfect for small areas where you need high speed and low cost. WANs are necessary when you need connectivity across vast distances, even though they are more expensive and slower, right? So that's it for today, friends. I want to thank you for listening for the in this lecture patiently, and thanks a lot. Uh, I have posted this PPT in my description box. You can make use of it, and if you have any doubts or queries, just ask me in the comments. Thank you.